We're the TE Connectivity student team, and we're going to be talking about how we performed analysis to identify patterns in TE's distributor network to maintain a sales level while minimizing cost. So a little bit of background for people who might not know TE. TE Connectivity is a technology company that designs and manufactures connectivity and sensor products for a variety of industries such as automotive, industrial equipment, aerospace, defense, etc. And their business model essentially works on, or a part of their business model works on selling these parts to distributors who then in turn sell them to end customers. And the task we were given was to basically optimize this distributor network or start about how to think we can optimize this distributor network. So today's presentation, if you guys can see the next slide, is going to be focused on first doing a little meet the team, then having an executive summary of what our research or study was, then talking about historical distributor optimization, followed by a summary of distributor clustering for forward-looking optimization, and we will end with recommendations. So our team consisted of the 7 of us. Sarah and I were the business leads. Mayan, who is a data science master student, was our technical lead. And Claudia, Ahad, Christine, and Krish were our wonderful data analysts. So just a quick summary of how this project went. As I said, the problem was optimizing the distributor network, and we conducted 3 main kinds of analysis. The first analysis was to develop descriptive and probabilistic models to identify which distributors in the data had already been optimized by TE in the previous years. The second analysis was to conduct a k-means clustering of distributors around similar sales metrics so that TE could then think about optimizing distributors within a given cluster. And then the last model was to enhance this clustering model with a term frequency approach. And this was essentially in response to having not so good results with the second approach. And we will talk about this in detail further. The findings that we had from these studies were that first we identified 4 distributors that had been adjusted within the TE network, but since they had less than $25,000 in annual sales revenue, this was really not sufficient for us to estimate market sales loss. We also used another probabilistic model, which is Professor Fader's BG and BD model, which identified around 100 distributors that in fact could be terminated. We also found 3 distinct clusters of distributors, but then we lacked sufficient network optimization data, which again made it difficult for us to estimate market loss. And eventually, recommendations for future analysis, we mainly talk about how we can improve this analysis to get realistic ideas of network market loss. And we will talk about a lot of these aspects in more detail now. So I'm going to let Ahad talk about optimization.
Yeah, hi guys. So our first method to kind of get an approach of figuring out what the historical optimized distributors were was basically to sort through the data and figure out 6 consecutive months with 0 sales quantities. And so the distributors that met that requirement were considered to be optimized. And after running that, we identified around 800 unique customers. And in TE's data, customers include distributors and end customers that TE sells directly to. And so when you take out the end customers, we were left with 4 distributors that were considered to be optimized. And we didn't, as Ashna mentioned before, we didn't think that was suffice to kind of base further analyses on. And so we worked on a method 2, which Ashna can talk about.
Yeah, so the other method that we used to identify distributors was Fader's buy till you die model, in which we basically say that each distributor buys some quantity of products from TE every year with some probability, and they will continue to buy with some probability in each of the years we have in our data. And based on recency, frequency, and monetary value metrics, we come up with a probability estimate of whether or not we think they are still in the system or have terminated. And So with this model, we identified roughly 100 distributors who seemed to have terminated in 2019. But there were two problems with this. One was that the monetary data had negative values, which is not compatible with this model. So we were forced to rely on sales quantity, which is not a good proxy because different parts have very different sales quantities. It's not a standardized product. And the second problem was that in a network of roughly 800 distributors, it's just not realistic to say that 100 of them just churned in one given year. So this is kind of overestimating, whereas a descriptive method was either underestimating or being accurate. But the pro of this is that it is probabilistic and considers historical trends, and so it has larger applications with customer lifetime value, which is something that can be explored in further analysis.
So our second method for analysis was distributor clustering using k-means. The idea behind this analysis is that we believe that similar distributors will exhibit similar behaviors in the event of a network change. And so if we can cluster distributors, then we can use the cluster elasticity or cluster growth to help predict what will happen in the event of a network change. Currently, the data on the network changes aren't robust enough to actually conduct this analysis, but because we have these clusters, if there were better data in the future, then TE could run this analysis using these clusters. So the methodology for creating the clusters was based on the k-means clustering method, and we're going to only look at a select group of distributors. TE has thousands of customers, tens of thousands of customers in their data set, but a lot of these have low average annual sales or are not distributors, or because of some data quality issues, don't match up in both the point of purchase and point of sales data. So we had an annual sales threshold and only used distributors who were in both the POP and POS sales data. This gave us 354 unique distributors, which, as I'm sure some of you guys know, is not that many to do a clustering analysis on, which is why we had some struggles with this clustering. We had to also come up with our metrics for clustering. And initially, we used a lot of the POP metrics, the descriptive metrics, but we found that that was not really giving us a lot of good results, in large part because regional or country dominance will inflate the data because TE has a lot of limited regions of operation. And so for the few distributors in some of these regions, that would kind of break them into natural clusters based on region, which isn't what we were looking for. We wanted something that was more about distributor behavior beyond just the region that they were in. To combat this, we used some dominance. So basically, we identified dominance as in, for a given distributor, for a given customer, how much percentage of that customer's revenue is attributed to this distributor. And we can do similar analysis for industry and product types. And we also use the number of exclusive end customers. That's for a given distributor, how many end customers do they sell to, that they're the only distributor who sells to those end customers. And finally, on average annual revenue. The final model, briefly, was a 3-cluster model. It had 108 distributors in the first cluster. This was kind of the middle group. The second one had 76 distributors that contained a lot of the higher earning distributors, but also had lower customer dominance. And then the second cluster, or our third cluster, cluster 2, had the rest of the distributors. It had slightly higher dominance in terms of industry, product, and regional, and the highest customer dominance. And using this model, TE can do, once they have the information on network optimization events, they can use the cluster's elasticity and growth to predict future revenue changes. And so finally, onto some recommendations for TE going forward. First, there's some additional data validation that needs to be done. We think that there's some data quality issues that TE can address to help to run the kind of analysis that they're looking for. As well, there's some interesting sales quantity and sales amount information that doesn't really match up. So we'd look to have this kind of data validation done on TE's end so that they can better conduct analysis in the future. Secondly, echoing kind of what I just talked about in terms of loss estimation and end customer churn. Once they have this adequate data, they can look at how end customers tied to distributors and overall revenue may respond to a network change using a cluster analysis or some other analysis. And finally, to incorporate some industry level trends and macro data. So in addition to optimizing their distributor network based on revenue or quantity, you can look at how specific industries or geographic regions would respond to adjustment based on kind of the industry-wide trends as opposed to TE-specific trends.
Great. Thank you. This looks like wonderful. I see a quick question. I think we are good with time. There's a question on chat. And I think this was wonderful, kind of, learning for the team, learning for TE as well. The question on chat is, based on what you did in the last few weeks, would you have done something differently if given a similar opportunity in the future? Anything, any steps, anything that you learned, which perhaps you can give back to the future generation who may be engaged in something like this?
Yeah, I think one thing that would be very important that we kind of struggled with in the beginning was just trying to understand the logic of the what if analysis.
Yeah.
And so when we were given the scoping document, it was in the form of a what if analysis, and we tried to be very optimistic about predicting the future. And so I would say that trying to think about more concretely what data you have and what you can deliver with that, I think is very important. And sort of setting realistic targets for yourself in the beginning after exploring the data, I think is very important, which is something we ended up doing, but it was kind of later than we should have.
Yeah, wonderful. And again, I think we have time for maybe one more question. I'm looking at chat. I'll ask mine. I think this was wonderful in terms of looking at how the team took lots of different types of data to come up with different kinds of predictive and prescriptive models. Any big hurdle in your mind? Where was the hurdle in kind of, as you mentioned, Ashna, in data collation? Was the hurdle in once the data was done, setting up the model? Would be great to hear again for those of us who are participating in the session. There are lots and lots of different moving parts in any project. Would be great to hear.
So another problem that we faced was that, so TE has had very few distributor optimizations in the past few years that the dataset contains. And so the data points that we were working with that were sort of like given in the dataset were very few, which means it's very difficult to create predictions based on that. So we identified 4 optimized distributors. I believe TE had around 10 or 5 or 10 optimized distributors, which is too sparse a data set to do any meaningful machine learning based analysis. And I'm sure other teams feel this way too, but like we live in a very buzzwordy world and get caught into machine learning. And so thinking first about like the limitations of the data and then back working from there about what it is that you can do with it, I think is a good idea, because we started doing the clustering model and then we realized that it would be very difficult to have anything meaningful or have a model that converges. And so we really had to be scrappy and make a lot of modifications to it, add the dominance parameter, think about probabilistic models. But I think sort of back working from the limitations of the data is very important.
Great. No, thank you. I sometimes I'm looking at the time, if you don't mind, Ashna, just unsharing it so that the Comcast team can get prepared. But going back to your comments, I tell the class sometimes when I'm teaching that sometimes you don't need a bazooka to hit the fly. You can use a fly swatter. I think keeping the problem at hand and kind of understanding how things are going, I think it's quite important. Thank you so much.